Hey everyone, this is C++ 101 Week 3B. It is Friday, April 27th, 2012. I'll be here, and my name is Nelson, and so will Gavin.
Hello out there in Buzzland.
Hey.
That was a special request for Chris. He said, get your best Jason voice ready, so I did.
Yeah, I guess we can start talking about code.
Excellent. What's on the table today?
The first thing we're going to do is we're going to look at strings, and we've been avoiding strings for a while because they really do need a good length of time to sort of talk about. So let's go ahead and fire up a new project, and we're going to be talking about how we can deal with strings inside of C++.
So this is string theory, is it?
Yeah. It's about as complicated, to be honest. Okay, so what do I mean when I say string? A string is a bit of text in programming. Almost every language has the concept of a string in it, and basically that's just a way to represent a string of characters. Individual characters that make up, well, a string, and that could be a bit of text. And it's very important to be able to store this text so that we can do various computations on it and make our life a whole lot easier. Now, in C++, strings are not as trivial as they would be in other languages that have a little nicer support for them. You won't find a string. Well, you will find a string class in the standard library, but it's not as built in, I guess you could say, to the entire ecosystem as would a C# string or JavaScript string.
So what happens if now I just decide, right, I need a string in main, strings bob equals you. Go on. What does it say to me when I type?
Well, you see, here's the problem, though. Because the way strings are represented, there's no easy answer to that. There is a string object in the standard library, and we'll be using the string object and talking about it. But that being said, C++ natively, the way it deals with strings are what are called character pointers. And I know that sounds really scary because we're not going over pointers until week 6. So, yeah. Actually understanding the way that C++ will want to store our string characters might be a little confusing until we get into pointers. That being said, dealing with strings is something that is so important and so vital that we're going to go ahead and talk about them today. So by default, we have what are called string literals in C++. And what is a string literal? A string literal is a bit of text encased with double quotes. With a semi at the end of that. So this is a string literal, meaning this is literal syntax that has a type and a value. Just like how my number equals 10, this is an integer literal. So this string literal syntax in C++ is convertible to, like I said, a character pointer, or more specifically a constant character pointer. The way that we would represent storing this bit of text in C++ without the ability to use the string object is going to be something like this. Const character pointer stir equals hey there.
So does that mean that once if that's a constant, does that mean once you've assigned hey there to it, you can't do anything with it? You can't change it. You can change it to Wibble.
Yes and no. This is a constant character pointer, not a character constant pointer or a constant character constant pointer. Yeah, constantness.
What you're saying is it's a constant character pointer as opposed to a constant which is of type character pointer. Or is it? Is it constant?
Kind of.
Is it a character pointer?
Yes. There's different rules about constness and pointers in C++ that we're not going to go over yet. So the point is not to understand this data type. The point is to see nakedly how C++ will want to store your integer literals.
Okay.
Now, you can also store character literals inside of character arrays, which is also very nice. We can say character array of 10. So let's talk about this for a second.
Isn't that much more like what happens in, say, C#? With the string that's in C#?
The string in C# is a reference type, meaning it behaves more like this than it does this. What this does is this allocates 10 characters that we can access when the stack frame of main is pushed. C# does not store strings on the stack. It stores them on the heap.
Mm-hmm.
What's a pointer? Well, I just wanted to point, no pun intended. I just wanted to point this out just to kind of lead into what we're going to be doing in week 5, because we will be explaining this in depth in week 5, and B, to kind of show people a sort of patterns that they might see in other people's code, where they see constant character pointer or const char star. What does that mean? What it means is that is a C style string variable, I guess you could say. But we're not going to be covering that in depth. Instead, we're going to be talking about character arrays and string objects. So a character array is essentially what a string can be represented as. So what this does is this initializes, or declares rather, doesn't initialize anything, that we now have an array of 10 characters on the stack in main. Does anybody have any questions about arrays? Because I know we talked about them last week, and hopefully people are aware of the open office hours where they can ask these sort of questions, but you guys are going to get really lost if you don't know, if you're not comfortable with the arrays quite yet.
People seem to be mostly there on the arrays thing. We had a couple. Can you give a 30-second thumbnail sketch of stack and heap? There's a few questions about that.
Yeah, it has to do with how memory is allocated to our program. For example, int main, when this function is invoked, int main owns some data. So for example, it owns my number. This data is made available to us when int main is invoked. However, that's not very useful for a lot of different programming problems, because a lot of problems do not have a set amount of memory that you need to solve a problem. For example, if we have a problem where we want to find the average of a list of products, we might not know how many products at compile time we need. Therefore, we can't instruct the C++ compiler to make available to us the amount of memory that we need when main is invoked. So instead we do something called dynamic memory allocation, where at runtime we ask the operating system to give us a little bit more memory during runtime that we then have to manage ourselves and eventually at some point give back to the operating system.
And so that little bit is the stack, and the bit that we know about compile. So the amount we can work out we're going to need in advance is the heap, and
the other way
anything.
The amount that we can work out is going to be the stack. It's the stack frame of main. And then the dynamically allocated memory is on the heap.
Okay.
Yeah, so strings. What we have here is a character array, and that's a simple way to represent a string in C++. Now you'll notice some limitations about this. First of all, it is a character array. It's not anything dynamic. It's all statically allocated on the stack, and we can only have a character or string of 9 characters in length. I'll show you why. Let's go ahead and fill this string up with stuff. Okay, so I've essentially put together a string here. I've created a character array with 1, 2, 3, 4 characters defined in it that are very specific. But here's the problem about this code. I mean, I can just demonstrate it.
Well, can anyone guess what will be output by this code? Who wasn't in the previous class this week and has already been told?
Some people say error, some people say nothing, some people say hey. Okay, let's go ahead and run this and see what we get. What we've in effect instructed cout to do is we've in effect instructed cout to print the characters HEY exclamation point and then continue to print characters in memory until it runs into a very specific control character that specifies the end of a string.
And did you see what Bando just put in BuzzNet?
Oh goody, the compiler has filled in the rest for us. Not necessarily. Even if this was an array of Okay, can anybody notice a problem with this code? I just made a huge mistake, even though the program runs. And I'm not talking about the gibberish yet. I'm just talking about, can anybody spot an error in my code that won't necessarily manifest itself? Yeah. Don't you love C++? Anyway, so even if this was an array of 4 characters, you'll notice I still get the garbage out here. That's because C++ works with what are called null terminated strings. Now, not all languages have this. For example, C# does not have null terminated strings. You can place null characters in a string if you wanted to. Of course, you would break interoperability with other languages, but you can. Ooh, happy birthday, Andrew. So basically, what we have to do is some way inform the runtime that, or inform cout specifically that we want to terminate this string. So we want to add in a null character. Now I want to point out something. This is equivalent to this, which is equivalent to this, which is equivalent to this, which is also equivalent to this.
Yes, don't get on your soapbox again. We know it's a stupid language for that.
The point is this character, even if it is equivalent to other things, even if it is truly just the numeric 0, I beg everybody to use the specific control character /0 to represent this character. Because, remember, C++ is incredibly liberal with types. If it can stuff a number in something, it'll let you stuff whatever you want. You can stuff Boolean values and double values and float values and blah, 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 blah. You can just throw things at data or at memory, and it'll just work sometimes. But I just want to point out that this specific control character is designed specifically in the language specification to denote that it is the null termination of a string. So I really want people to use this syntax when defining the end of a string. So now when I run the program, I just get hey.
And yes, single quotes are the indicator for a char, in the same way that double quotes are the indicator for a string literal.
Right. So are there any questions about code so far?
I think you pointed out on Monday about with the single quotes, it just needs to be single quotes and the character that you're aiming for.
I don't know why this is valid. Ooh, Bando, make sure that you have enough memory allocated for your character array. Otherwise, you'll get a stack thingy doohickey stuff. Okay, so I don't know why this is valid. I don't know what the specified output of this is supposed to be. But you can, or maybe that's too many, you can put a variety of stuff into character literals. And I'm not entirely sure what the purpose of that is, but you can do this. And it's not going to give you something that's particularly useful. I've seen a lot of people do this in the past. I don't know why this syntax is popular, where they add spaces between the character, but as a result, you get a bleh. Like, and when I say bleh, I just mean a garbage value.
It's just taking the last character of whatever you put in that array. You'll get ze this time.
Ah, okay. I never paid too much attention to it. The only reason I pointed out just because I've seen this so many times that I just need to point this out. Okay.
And Chris, we're getting there. We're nearly there. Don't worry.
What would happen if you used the escape character on the 9th position in the array? If I had done this, if I had set the 10th index to the null termination character, what would happen is everything between my text and the null termination character is going to be the garbage that existed inside of the array. So you typically wouldn't want to do that.
Presumably the same sort of thing would happen if you put a normal character in the last spot in the array.
But then it wouldn't even end there. You see how A is right there, and then it just keeps on going? And prints a smiley face. Hey, I got a smiley face.
Well done.
Okay, so you generally don't want to do that. You really want to terminate when you're done representing your text. I do.
But Nelson, it feels like there ought to be a better way of doing this.
Yes, there is.
Ellipses.
I want to point this out. The string literal syntax is assignable, even though it is a character pointer, but it is assignable when you assign it to it in the initialization to a character array. In addition, this takes up 4 bytes, 4 characters, because when you use the C style, the string literal syntax in C++, it will automatically place the null termination at the end. I also want to point out that you can omit the length right here. So I could say, hey there. And you'll notice that if I hover over this array, it says char array of 11. There are only 10 characters here, but the 11th comes in because of the way that this works.
With the null terminator.
Can you put numbers in a character array? Ah, yeah, you could. Any guesses as to what this is going to print out?
Mm-hmm.
We had some nice little ASCII codes, and actually, that was a bad example. I think I meant to do.
You should have been aiming for 49.
Yeah, I meant to do that something in the 50 range because I wanted numbers to print out. But yes, you can store numbers in there, but they're just going to be whatever. Okay, so is everybody good with character arrays so far? Character arrays, awesome stuff.
Marcel asked a good question. If you null terminate at ID 4, but instantiate the array size of 9, do 5 to 9 become unusable?
No.
They just unused memory?
It's just not used. It's still allocated to me, to the main stack for me. It's actually not to me. It's allocated to main. When main gets invoked, the memory required to allocate this 10-byte character array is created for us. And the memory that is after the array's null termination character, but before the end of the array, it's just not used memory. But it certainly is usable. And it is reserved, and it's not going to get lost.
What the heck did you get weird numbers for? Do you mean if you type 51 you get 3? Whoever that was, Adam. Yeah, it's the ASCII code for that particular character. So, and 49 is 1. I just happened to remember that, and the numbers go up from there. So 51 is 3, and so forth. I can't remember where the letters start.
Can't character only hold 1 byte? Yes, I want to point this out. Characters only hold a single byte, which means our favorite multicultural aware text encoding called Unicode is not going to be possible to do with normal characters. I mean, it kind of is, really, because even though these are just single bytes, sometimes, like let's say we're encoding in, let's say UTF-8, where certain character code points get multiple bytes, we could still represent that in a character array. That would just be fine. But if we tried to print it out with cout would not be aware of the encoding and wouldn't be able to properly print it out. So basically, if you want to do Unicode, you're going to have to use the wide character, which we are definitely not going to be talking about here.
Cool.
Because that gets into some horrid stuff. Okay, so let's talk about strings. I guess it's time. Because, again, these are character arrays, just a basic intro to null-terminated strings, how null-terminated strings work, I guess.
Cool.
But there is a nicer way.
Include me, baby. No response.
It doesn't compile.
I am not a string.
Is there an easy way to clear out an array? There is. I guess you could say you could do this. This will set everything in the array to 0. I do want to point out, though, that I typically won't initialize my arrays to all zeros, except in the case where think about it this way. Give every variable in your program sort of a flag that you mentally set and unset. And that flag is called, is this variable initialized yet? Basically, if I have an array, I don't care that it's not going to be initialized, because I'm awesome like that, I will initialize it fully before use and provide it some sort of proper value. For example, if I have an int array of 10 and I immediately turned around and said for int I equals 0, I smaller than 10, I plus plus, c and get r at I would not pre-initialize this array because I'm immediately turning around and filling it with stuff. However, if I had this, then I would initialize array to 0. Because even my level of initialization right here might be fewer items than what the array can hold. And after this for loop executes, I want to think of this as a fully initialized array. So I would, in this case, initialize this to 0, because it's possible after my initialization code for not all of the items to be filled.
Also, it doesn't always make sense to initialize to 0 anyway. I mean, if you're doing something like a lives counter in an old-fashioned game where you've got 3 lives each game, you might choose to initialize to 3 instead.
Yeah.
Or to another number.
Yeah. It really depends on the context of what you're working in. As far as what you initially... 0 is a common value, but there certainly are other situations where it's not the appropriate value. How would you do that with for each loops? C++ doesn't have for each loops. We are going to be covering range-based for loops today, but that's not even a feature supported by the compiler I'm working on right now. So we'll get into that. Then why do we not have to initialize the remainder of array of size 9? Think of it, well, look at this. It has to do with how char arrays are designed to be worked with. In this case, it does not make sense to initialize array to anything. We're just wasting cycles. Because as far as everybody, every other library, every other developer, every other entity that's capable of understanding C++ code goes, the null termination is enough. They're never going to read past the null termination because that's a convention that isn't broken. There's no reason to waste the cycles to initialize the memory here, when we're already providing to anybody who's going to consume this data a very specific and conventional means of specifying the length. I wouldn't bother with it. Would just be wasted cycles. There'd be no point. Brady, I was thinking actually about going over it either right before break, right after break, or during break.
So approximately break then.
Yeah.
Strings.
Okay, so strings. So what's the biggest problem with character arrays is they are of fixed length. Because all the memory must be known ahead of time, there's no way to store a multiple length array. Now, well, of course, what we could do is let's say, okay, so let's do a simple problem here. We want to store a list, an array of 4 items. We want the user to be able to type in the names of those products. I guess not items, products. We could do this. We could say char product names equals, or sorry, not equals. Let's say 4 product names of a maximum length of 20. And we could say for int I equals 0, I smaller than 4, I plus plus. We could say product names at I cin, or more specifically cin.getline, which I'm going to be talking about here shortly.
So sorry, I don't think you've covered this yet. Is product names a multi-dimensional array then now?
Kind of, but it's not useful to think of it like that. It's more useful to think of it.
You haven't covered the double array.
I'm not really semantically referring to this as a multi-dimensional array. I would rather refer to it as a string array or a character array. In that there are 4 times 20 elements in. I'm just saying
you haven't explained that syntax at all.
Right, and so what's going on here is we're creating an array and of 4 items, and each one of the items is a 20 length character array. So you think about this as 4 product names with the amount of characters allocated for product names being 20.
Okay.
Oh, I don't think we covered for loops either. We're covering for loops later, so you just got a sneak peek. Okay, so what we can do now is we can go ahead and hit F5 and type in 4 product names. 1, 2, 3, 4, and then our program terminates. And then that gets stored in this array, and everything is peachy. But here's the problem with this code.
Does it really get stored?
Yeah,
I've seen no proof of that. No, you can't write half a program. It's disgraceful. You nearly typed pony then.
Oh, come on. So as you see, all of this stuff does get stored properly.
If not spelled properly.
Yeah. But here's the problem. We can do this. We can, again, I mean, I guess we can back up and just ask if anybody has any questions about this code. cin.getline is a way to store data from input into a character array, and we specify specifically to cin.getline how many items that array can hold.
Do you have to specify?
Yes.
That there.
You do have to specify, because remember, arrays in C++ do not have a length that is known to anybody but the person who instantiated it. Every time you pass an array around in C++, get used to passing around a corresponding length of that array.
Okay.
Well, what was that okay for? It sounded like I offended you or something.
No, C++ did. No, actually, I was reading the questions panel at the same time. I was going,
Okay, I got a question in, shouldn't it only be 3 letters? Basically, what we're doing here is we're saying, give us 4 arrays of 20 items. So we're saying like this, char product 1 name of 20 items, 2 and 3, or sorry, 3 and 4. So we're saying, give us this data, but stuff it in an array for us. So again, to read the syntax, we are asking for 4 20-length character arrays.
It's actually, it's product 0 through product 3. Which
Right.
might be where he's getting tripped up, I being 0 based.
Yeah, arrays are going to always be 0 based. Do arrays have length in C++? No, they do not. There's no length property of arrays in C++. There are no properties on arrays in C++. Arrays are nothing more than a contiguously allocated block of memory. They have no behavior, they have no functionality, and they contain no data other than the data that we tell them to contain. Okay, so does getline add the null terminator for us? Good question, it does. Getline does add the null terminator for us. So you can't count the number of items in the array dynamically? You cannot. You can statically, but you cannot dynamically. So for example, I could say int number of product names equals size of product names divided by 20. I could do this, but I want to point out really quickly though, and let me just verify that that's going to be, that I'm not going to get any crazy, yeah, there we go. When I do this, this is done statically. This is all done statically. The only reason this returns the correct result is that sizeof is a static thing in the C++ programming language, meaning that it can only return a proper size if it is aware of the declaration of our variable. cin.getline is not aware of the declaration of our variable, and therefore is incapable of knowing the size of our array. All it knows is that we passed in an item that is typed to an array type. It does not know anything about it other than that. So we have to specify how long each one of the strings are. So every time you use sin.getline, you have to declare the length. Can you just take a cut version of it, i.e. part of it? Yeah, you could. I could say only fill up 10 characters if I wanted to. But cin.getline will always require the length, which is one of the, actually I'm glad I went over this first, because this is one of the things that strings allow us to do that we would normally have to do.
So what's the difference between cin.getline and getline with cin and product names for by as parameters?
This will not even compile, is the difference. Because getline, the method, expects us to pass in a string type, which we haven't covered yet, which we're about to cover. And the reasoning is getline expects a string object, cin.getline expects a character array. How would you measure the size of each item put into getline? You could do. You could use a method called strlen. Strlen is a function. It's a very, very simple function for us. That simply counts how many items are in the array until it hits the null terminator. So that's how you would get how many items.
Is that inefficient?
Well, it's inefficient, but it's the only way to do it, unless you have an object. There's no other way to do it.
Yeah, I know.
It's not pretty.
But I mean, is it because obviously you're basically doing a search through the whole length of the thing?
Until it finds a terminator. cin.getline truncates the user input, yes. Is the length of the string equal to the size of the string? No. The length of the string is how many characters you can count forward until you hit a null terminator. The size of a character array is determined by the size we define right here. So even though product names I might be only 3 characters long, it still is taking up 20 bytes of memory.
And also, I mean, the size is going to be in bytes rather than the length, which is going to be in,
well, yeah, characters, but with
characters.
With normal characters, they're synonymous, but not, of course, when you're dealing with UTF-8, meaning that you can't use strlen with Unicode strings. Can't you just do size product names I? You can do this, but this is going to return 20. As you see, which is 20 characters long. The reason you can do this is because at compile time, and I need to stress this, at compile time, the compiler knows that this variable is typed to a character array of this length. This is not performing a runtime computation. It's not a runtime operator. It's not going to change at all during runtime. It's going to be compiled in as a static number, which means that it's only valid to use the sizeof operator in the context of a function where you declare the variable you're asking the size of. If you're in another function, you will not have the compile time knowledge of using the sizeof operator.
It's more, it really ought to be named total size of. Essentially, if it'll tell you how big it is.
Yeah, but only if it's known at compile time, not if it's not at runtime.
Well, yeah, no, I mean, but if you've only got 3 things in it, it's still going to tell you it's a 20-character string.
Yep, because that's how much memory is allocated for it. If product names I wasn't defined and had no null characters in it, will it continue to count outside the boundary? Sizeof doesn't count characters, but strlen would. Strlen would just sit there and just go over and over. If product names that I did not have a valid null terminator in it, strlen would just sit there and spin its wheels until it happened to cross a null terminator somewhere deep in the bowels of your memory. So string object and character arrays are used differently. Yes. Segfault, D. Well, important note, how the heck do you know what is runtime and what is just done through compile time? You just have to know. A function invocation is going to be a runtime thing. The sizeof operator is going to be a compile time thing. So I just need to point, you just have to know, So for example, character product names 420, this is a compile time thing because we're informing the compiler how much memory to allocate for our program. And that amount of memory will not change depending on runtime environment. It's not a runtime thing because we can't allocate a variable amount of memory. Okay, so moving on into strings. Strings fix a lot of these issues. Now the string object is, or the string class in C++ is a part of the standard, and it is a class, it is a type. It's the first real object that we're going to be working with inside of C++ here. It's really interesting. So to access the string library, we need to pound include the string header. And to use the string, it's very straightforward.
Yes. What segfault said.
Oh, hash, whatever. Still. Okay, so what's going on here is string is an object, meaning that string carries around a bunch of data and behavior that can be invoked on that data. Now, some very important things to know about string. Strings can change during runtime.
Well, I mean, did you just say that a string has got state and behavior?
Yes.
I mean, it sounds an awful lot like it's an actual class rather than just some data in memory.
Yes. String is a class, and we can use it to create objects inside of our program. So it's not a simple primitive data type like int and bool and float and double and character and shorts and longs and blah, blah, blah. You can't make an unsigned string. That doesn't make any sense. A string is a type that was defined in C++ code, and it performs a lot of behavior for us. One of the most important things about C++ strings are that they are going to be mutable, so we can actually edit the data inside of them as we go along, and that they allow us to store as much data as we need to represent something. Why is string not blue like in C#? Yeah, what Craftsman said. Nelson, why is the text all blue and green and black? It's just how it is. In the Visual C++ editor. Remember that the Visual C++ editor is fundamentally different software than the Visual C# editor or the Visual F# editor or the Visual Basic editor. Although it looks deceptively similar, the underlying code bases are a lot different, and the C++ editor simply does not support the features that are available in other editors. One of those features being highlighting classes' particular colors. I do want to point out that in the Visual Studio 2012 beta, it does highlight your classes, which is nice looking, but not in Visual C++ 2010. Okay, so yeah, we can now do this. We now no longer need to worry about the length of the strings we're working with. Not only that, we can also ask the string how long it is by invoking a method on the string object. So you'll notice when I type in str dot, I get this nice little list of members, which, you know, it looks a lot similar to sin dot. In fact, this is pretty much made of the same stuff. Cin is an object, just like str is an object. Of course, their classes are different. Str is a string, is instantiation of a string class, whereas cin is instantiation of a iStream, basic iStream. I forgot what cin was. Now this is going to bug me. Yeah, it's an iStream. Boom. Okay, so the string class provides us a lot of cool methods or functionality we can perform on this object during runtime.
Such as?
Well, the two ones that we're going to be looking at today are going to be count or length and size. Now, can anybody tell me what the difference between length and size is? And if it's not anybody, if you already know, I can know the answer because you happen to attend Monday's class, then please don't ruin it for everybody else.
So can anyone who doesn't know the answer tell us the answer? Sorry, Derek came out.
That was a. If I know you know the answer, don't answer.
Nice. Is that answer or this answer?
It's that answer.
Is this that answer?
You would hate JavaScript, Gavin. So many cases I create a variable called that and assign it to this to work with the closures.
Yeah.
It's lots of fun. Okay, so we got a lot of answers. The answer is length and size both do the exact same thing.
What?
There's no difference between the two. The only reason they exist is the only reason size exists is to make the class look similar to other containers in the standard C++ library. And the reason length exists is because it just looks better on a string. So, yeah, they both do the same thing. And that's how we can get the length of a string. So that's really nice and awesome and great and stuff. So let's talk about how we can stuff things into strings, because that's where things get really interesting. Let's go ahead and stuff something into a string. Let's go ahead and say, cout, enter your name, cin stir, cout, your name is stir, sin.ignore, build, run, enter my name, Nelson, enter my name is Nelson. Sweet. The program knows my name.
Cool.
However, what happens when I type in my full name?
It dies on its own.
What happened is in C++, when you ask sin or cin to fill up a string variable, what it's going to do is it's only going to grab the first word that you passed in, and it's going to leave the other words on the buffer, which of course is going to trip up our sin.ignore and our sin.get, and the program is going to terminate immediately. So the way that you would typically use cin is through the getline function. And the getline function accepts two things. It accepts an iStream and a string. So remember, there is an object that we have access to that is of type iStream. iStream. That we have access to that will work quite nicely here. It's cin because we want to grab a line from the console. What string do we want to pass it into? Let's pass it into stir. So by doing this,
yeah.
we get...
I don't believe that's really your name.
What if it is? That would be an awesome name.
Sadly, as Musaru pointed out, that name is true.
Yeah. Sadly. Okay, so what's going on here? I mean, it's actually kind of straightforward to see. Getline will simply take the iStream and fill it up with all, or fill in the string we passed in with all the characters until we hit a new line.
So if you had enter your and then a new line name.
You mean just hit enter?
No, new line in your with an escape character.
You mean right here?
Yeah. I'm being very dim, aren't I?
Yeah. So we get this.
Sorry. Long week.
Yeah, I wasn't quite sure what you're asking. But anyway, Craftsman asked, so in C# would it be like getline, cin, out, stir? If you are familiar with the out modifier in C# or in similar languages, I do want to point this out just because these people who might be aware of these other language constructs might be thinking that, you know, they kind of see what's going on here. And the answer to that is you're not. Because what's going on here is a reference.
It's like seeing restaurant.
Yeah, and we're going to be... No, it's not like ref in C#. It's different.
But you just said...
It's a reference. It's a C++ reference.
Oh, okay.
It's not a C# ref. And we're going to be talking about references when we start talking about pointers, because they are behaviorally similar.
Yeah, it's just because you said it's not an out, it's a reference. And so I assumed you meant out, ref, out. But yes, okay.
Okay. So, basically, and I didn't mean that, I just wanted to point out that we are going to, I mean, I know I've said this a lot, but week 6 is going to be a lot of fun. But people need a lot more context before getting into that. Okay. So
Do you want to set them up something to practice this? Just getting input and output.
well, what we could do is someone did ask a question, can you have an array of strings? And the answer is yes. So what I want everyone to do is go ahead and hit participate if you are feeling up to participating.
They're going to want to know what to do first.
They don't get to know what they do, what we're going to do before they commit to
You're
it.
asking for volunteers for a secret mission.
Yes. Hit the participate button. Okay, what I want people to do is to have a string array using std string of 4 items in length. Terribly constructed sentence. Allow the user to enter data for each item in the array, and finally print out each item.
Using std string, is that any different to you including it like you have?
No, it's basic. This is std string. If you hover over it, you see it's defined in the std namespace. I just wanted to say a string array to avoid ambiguity with C-style strings or character pointers or character arrays. I wanted to specify that we're going to be using the object for this. Okay, so write this code out and hit ready or ready when you're done. And I'm going to go ahead and pause the video. So we're back.
You're going to code this out.
Okay. Yes. Let's code it out. So,
yes, did you start the recording?
I did start the recording.
Marvelous.
Wow. That was like...
Not even close.
Yeah.
At least you got your semicolons back tonight.
Oh, come on. Again? Really?
You really want to show your for loops and take a hammer to your phone.
Yeah. Oh, really? Two errors. Wow, I'm just bad at this game.
But it's because you're doing that backwards. I wonder why you were doing it backwards.
Okay. I do know how to program, apparently. Okay, so, yes, what we have here
Walk us through it, then.
is the first time we enter a while loop that's going to run 4 times. So it loops from 0 to 4, or 0 to 3, sorry. In each one of the iterations, we invoke the getline function, we pass in cn, and we also pass in one of the item names that corresponds to the index that we're currently looking at. On line 16, we reset our counter and loop from 1 to 4. And I did this for display purposes because I wasn't thinking quite ahead. Typically, I would actually do this, which I probably should have done, but then I wasn't thinking because apparently I fail. So we start back at 0, and we create another loop that's going to increment from 0 to 3, and we print out each individual item, and we add one to the index just to make it look a little nicer to humans. So any questions about how this code works?
Let's see what NATO put in BuzzNet.
If you do cin, if you were to have done this, this would not give you what you want, because then you could say 1, 2, 3, 4 and hit enter, and that actually will fill up every single item inside of the array. Because when we do cin and use this syntax, it's only going to grab a single word.
Is there a way around that on cin?
Nah, not that I know of.
Short answer.
So that's why we use getline.
So what Nato did would work if you were guaranteed you were only inputting the one word.
Right.
But as soon as it finds a space, is that any white space? Does that work for tab as well?
I believe it does.
I'm waiting. Rizash said wait.
Oh, I thought you were talking to me.
No, I wasn't. But
I just blew up the program, apparently. Yes, it works for any white space character.
cool.
Alrighty. So let's move on to concatenation. Now this is where things get fun, and I'm actually going to show you guys something neat that wasn't actually in the syllabus, but then I realized it would be very mean of me not to include it in this class, because it'll actually allow us to use strings a lot more better. So what we're going to look at right now is concatenation. Concatenation is very straightforward, or at least it appears to be more straightforward. So we can say string my string equals Nelson. Now, in certain languages, this is acceptable, and this would be string concatenation. In C++, this is not acceptable. The reason it isn't acceptable is because, remember, these double quotes turn into character constant or constant character pointers. Because actually, surprisingly, constant character pointer is different from a character constant pointer.
Let's not get into that again.
And you cannot add a constant character pointer to a constant character pointer. And as a result, you get a nice little error. So
that's just silly.
How would we do this? Well, we could say my string, and we could say my string plus equals lk. This would work. The plus equals operator works with strings. So does addition. Addition will work between two strings. So I could say, for example, string first name equals Nelson, string last name equals lk, and string name equals first name plus space plus last name. And the reason this works is because the left side right here is a string, and a string can be added to a character constant pointer or a constant character pointer, and then this whole expression turns into a string, and a string can be added to a string.
So, and there are a few people going, which I think it turns out to mean, what does plus equals do?
Well, plus equals is equivalent to me of saying equals my string plus lk. And my string, because my string is a string object, it knows how to be appended to or added to a character constant pointer, a constant character pointer.
Well, really, it knows how to add a constant character pointer to itself.
Right. Oh, a string var can be added to a string literal, but two string literals cannot. Yes. Is there any way we can overload the addition operator for constant character pointers? I vaguely remember some esoteric aspect of C++ called friend operator overloads, but I cannot remember their specific syntax or if they would be applicable in this situation. So the answer is probably not. So you're saying that the constant character pointer isn't an object, so you can't add two together. Yes, a constant character pointer is a value. It's not an object, meaning it has no functionality defined given the addition, subtraction, or whatever operator. Okay, so let's talk about something a little bit more important. How do we add, how do we append, or how do we convert between a number, an integer, and a string? For example, so what I'm going to go ahead and do is I'm going to say send.ignore and send.get right here. I'm going to hit F5, and I'm going to enter my age as 49, and my name is Nelson. Now, execution here is paused on line 16. No, well, that was a bad example, because we actually don't print this out. Okay, execution is paused on line 16. When I hit enter, what is the output of this program going to be?
An accurate assessment of you.
Nelson, you are 1 year old. 1 year old. Strings cannot be added to other data types. They can't be added to, you can append other data types to strings like you can in other languages, and you cannot convert other data types into strings in an easy or straightforward way. You have, well, it is easy and straightforward, but it's not obvious to a person who might be coming over from another
And
language.
Guideless, you were so close. It's actually 49 is the ASCII for 1, not the other way around.
Right. Okay, so let's talk about how we can get this program to work properly. Let's introduce the string stream class. The string stream class is a class that we can use, like cin and cout, that will allow us to stuff it full of stuff, just like we can cout and cin. Like, for example, with cout, we can stuff it with integers and doubles and strings and all that stuff, and it just magically knows how to deal with all that stuff. String stream works as
turkey in it.
Yes, we could also put a turkey in it, and a chicken, and what's the other one? A duck. Like,
The other bird that you've heard of.
No, it's this whole thing. Apparently, like sticking other birds and other birds is a thing. I don't know.
Oh yeah. Anyway.
So, a string stream behaves similarly to cout and cin, except for instead of printing out to the console, it gives us back a string that we can use. So, by adding in the include string stream header, we can go ahead and define an object of type string stream. So I can say string stream, which again is in the std namespace. I'm going to call it ss. And I'm going to use it like cout. I'm going to say ss name you are age years old. Now I can delete this output code right here and say string output equals ss.stir. Invoking the ss.stir method will pass back whatever string stream has in its buffer, but in the form of a string object.
Could you simplify that further with lines 20 and 21?
Well, yeah, I could.
You just directly...
I could. But
yeah.
I could do this, but I just want to point out that if you were just printing directly to cout, you might as well just have not used string stream. But if you needed to hold stuff into a into a temporary string variable, this is how you'd do it. You'd access the stir method. So now when
if you wanted to fiddle around with that string, then
right. Wait a sec. Oh, right. My age is first. So now if I type in 49 and type in Nelson, it gets properly formatted.
Riser brings up a good point, actually, which is why are numbers in strings not printed out in ASCII?
Types.
Types.
Types. Types. Cout is a templated object, or more specifically, OStream, the class that cout is instantiated from, is a templated class. And all the methods on it use templates. Because of that, cout and StringStream get implicit knowledge about the types that we're passing in. And so instead of acting naively about the data we're passing in, it gets additional semantic information about what we pass in. So it knows that age is an integer, and it knows that it's going to behave differently with that age. Now, that's not saying that the string class itself isn't. That's not saying that's impossible for the string class to have been designed to be aware of integers. But what the developers of C++ wanted was not to bloat the string class even further. So instead delegated the responsibility of converting between types and text and texts and types. It provides us the iStream, the OStream classes, and the StringStream classes. Why not just initialize string age instead of int? Well, what if we wanted to perform some computation? Like, for example, what if, and this is the highly top secret algorithm owned by 3DBuzz, what if we wanted to calculate how old you're going to be in a year? I could say age plus 1, and then I can say you are years old in a year. So now, because age is an integer, I can do that. So if I typed in 20 and Nelson, it would say I'm 21 years old in a year. So we want to store age as an integer because that makes the most sense for the type of data that age stores and allows us to perform computations on it. Can you convert a string value into an integer? Yes, you can. We're going to go over that next. But
are there any more questions on what we've covered so far about string and StringStream? Are you going to be covering input validation today?
no.
So see, Stillman, he knows, but he's not going to tell you.
He what?
Somebody just said, how can I prevent my program crashing when I put a char in for age? I just said, he knows, but he's not going to tell you.
Yes, because that gets into a discussion that we didn't have in Monday's class. We're going to have in next week's class. Alrighty, so let's talk about converting. Oh, Anthony asks, can we format numbers? The answer is yes.
You didn't talk about that on Monday either.
But we did point it out on one of our things. I can't remember which class we did. But there is a few things that we can do. I just can't remember the... here we go. If you include the IO man IP class, or a header...
Oh yeah, we did manip, because it's for manipulation.
We can do things like, for example, if I changed age to a float, I can set the precision of what I want to display by saying set precision to, let's say, 4. And when I run this, something not correct happens.
You had... You had 4 digits.
Either way, these sort of things are what you use to control to set those particular properties on them. And we're not going to go over them in great detail, but that's just one of the things that apparently doesn't work the way I expected.
Russell Stark pointed out that you need the fixed as well, but
Fixed?
no, both fixed set precision.
Right. Derp. There we go. So you use these little doohickey thingies that will change the way that your strings are formatted. This code does not work for me. What happens in your code, Robert? It just exits. Are you typing in a name into your age field? Because you'll get that behavior. If I type in a string into age, it'll just terminate.
And have you got the C in .ignore?
Yeah. Do you have the C in .ignore as well?
Do you want to show us your screen?
Yeah. Could we swap over to your screen real fast? Alrighty.
Hello?
Hello?
I got it to work. I don't know. Sorry for wasting your time.
No, that's all right.
I'm glad it's working, though.
No, that
The
happens.
threat of seeing your screen frightened it into working.
Must have been that.
Yeah. Alrighty, I'm going to go ahead and jump back.
Well, that goes down as the quickest fix.
Yeah.
So that's,
See,
that's
all I
good.
have to do is show up and things just
You're
work.
that good.
Yeah. Alrighty, so yeah, let's talk about actually converting from a string value into a something value.
Int.
Sure. Okay.
Let's take in an age. Get people to put in their age.
As a string?
Ask people for input. Get them to put their age in. And then get it out.
Well, I was going to do it backwards. I was going to say like string age or string age equals like 42, and then convert this into an integer.
Okay.
So basically,
Well, yeah. Oh, yeah, never mind. Okay.
so string streams can support pulling data back out. So if I create a string stream ss and say ss age, I can say int age int and say ss into age int, and I did this totally backwards. And as a result, if I go ahead and say cout you are age n plus 1 in a year, I'm 43 in a year. So that's really straightforward. A string stream works like a combination of C in and C out, but just at a... Yeah. It's awesome. Does anybody have any questions about string stream? So what data values can strings contain and what can't they contain? Well, a string can only contain characters, period. That's all it can contain. You can use the string stream class to convert back and forth between other types and strings if you wanted to. How do you prevent the user from entering the wrong type of data? That's something we're going to be covering next week. That gets into some input validation. Any more questions about string streams? Because we're about to be done with strings, actually. It's only been an hour and 15 minutes of recording.
They're not actually that complicated when you get down to the details of it. It's just remembering that they are kind of spread into the string and stream includes. And
right, there's no
it's just finding the bits you want to use. All the normal sort of behavior is available that you'd expect.
Yeah, it's just really spread out. All right, well, let's go ahead and talk about basic debugging. I believe we did go over basic debugging at some point, but let's go ahead and talk about it a little bit further. Okay, so what is debugging? Basically, Visual Studio contains what's called a debugger, and a debugger is a program that kind of sits beside our running program, and it monitors it, and it allows us to stop the execution of our running program and actually walk through the code of our program as it gets executed. It's a really straightforward concept, and it's just this whole section I'm about to go over is just a matter of memorization, basically. So how do we access the debugger? Well, first of all, we have been running our code in the debugger. By hitting F5, you'll notice that Visual Studio changes. It turns into its debugging mode. And you can notice up here that it says our program is running, and you'll notice some additional toolbars and some additional windows, and a bunch of cool stuff just pops up. So we're already running.
What if those windows? Sorry, I was leading you in a different direction. What if those windows don't pop up?
Yes, if your debug perspective does not look like this, the additional windows are available only during debugging from the debug menu down to Windows. So whenever I talk about a window, and if you don't see it, be sure you're in the debugging perspective and you go to Debug Windows and click on one of these windows. Normally, that doesn't appear. If I go ahead and say Debug Windows, only a few of them appear. Okay, so how do we break our code? How do we break into the debugger? How do we stop our code from executing so that we can introspect the state of our program as it runs and actually watch it execute line by line?
Hit it with a hammer.
Yes. The simplest way is with a breakpoint. A breakpoint is when I go ahead and click on the gutter over here, you see this little red doohickey thing appears. In addition, if I hit F9, that red doohickey thing toggles. So if I set a breakpoint here on line 8 and hit F5, watch what's going to happen. The program did start. The window is right here, but the execution of the program is paused. And it's paused immediately before executing line 8, which in this case is just a simple assignment. We're not going to be talking about all of these windows or all of everything in this introduction to the debugger. This is basic debugging. So we're not going to be talking about the call stack window or even the breakpoints window or even the output window. But I do want to talk about the watch windows, the local windows, and the auto window. And I want to talk about stepping over, and that's about it, really.
So what if we're focused on this index? Index is vital to the running of our country and the future of society in general. How do we know when it gets changed?
Right, so one of the biggest things about debugging is watching our data as it changes, and there's a variety of ways we can do it. The simplest way that you're going to be introspecting the data inside of a variable is by hovering over it. By hovering over this variable, we see what it is, or what's in it. You'll also notice that when you hover over this in Visual Studio 2010 and above, we get this cool little pin button. And when we click on the pin button, the value of our variable sits here and floats over to the right. It's very cool.
And it will do so even if you stop execution and then start debugging again.
Okay, so inside of our watch windows are also very important. Our watch windows allow us to enter an expression and monitor the value. So I'm going to monitor index by typing in index and hitting enter, and we see the value. I'm also going to monitor the expression index is smaller than 100. And you'll notice that that expression is true at the moment.
So you can basically type anything. You could type index over 2 is greater than or equal to the sum of
Right.
pi.
Yep. In our locals and autos windows, these autos are a best guess as to what variables you want to be looking at. Locals are all of the local variables of our current function.
So will autos, if you step through, will it you've only got one variable. I was going to say if a variable value is changed, will that suddenly appear in the autos window?
It will generally be something that is defined for a particular function. I mean, I've never really paid much attention to the autos window.
You just specify what you're looking at in the watch window instead.
Yeah, the autos window basically shows things that are around our cursor. So it'll show variables that are around where we're looking at. So if I jump down to here to line 16, index would disappear from the autos.
Gotcha.
So looking at locals, again, local variables, but I pay most of my attention to the watches because the watches are really powerful and awesome, and I also pay attention to the pinned watches up here that I drag around. Okay, so now let's watch what happens as we step through the debugger.
And how do you do that?
There are a variety of ways to continue execution. The simplest way is to set another breakpoint and hit F5. What I just did was I was sitting on this breakpoint and I said F5, which says, well, continue just running just like usual, which will ultimately hit this breakpoint here on line 15. Now I want people to notice something. Index at 100 right here. Index in this watch, and this expression all are red. And the reason they are red is since the last time the debugger paused execution, these values have changed. Okay, so that's one way to continue the execution of the program. There's a few other ways. We have the step into, the step over, and the step out. We're going to be focusing on step over. We're not going to be looking at step into yet, because the only things we're going to be stepping into are, well, standard library stuff, which is...
And for people who are used to using C# and stepping into things, like me, beware, it doesn't do what you expect it to.
Yeah, it's not very pretty. Okay, so we're going to be...
show them that in a minute. We'll show them what they should be doing first.
Yeah, basically, step over is what we're going to be doing. And step over is F10. What F10 will do is it will execute the line of code that we're pointing at, and then advance the pointer one more item, and leave the program broken, as in a paused, suspended state. So as I continue to hit F10, notice some of the characteristics of the debugging experience. I am stepping through this loop. And you'll notice that after I get after line 12, that these turn red again. Of course, this expression doesn't turn red because it's still true. So I can continuously step through this a bunch of times. And maybe 100 wasn't the best example.
I was wondering that.
So if I change this to 5...
And your expression.
And my expression.
And your yeah.
We will loop through 5 times. And you'll notice that index smaller than 5 is going to turn false, and we're going to continue on line 15. And I hit F5 one too many times, so this isn't red anymore. I hit F10 one too many times, but this was red for a second. How do I get the expression into the watch? I just type it in to the name. Is there a way to step back? Yes. You can click and drag this wherever you want to change what line of code is going to be executing.
Will that?
It'll work just fine. But I highly recommend against people new to programming doing that, because that will lead to very strange behaviors that you wouldn't quite expect. For example, I mean, just even like look at this. Like,
Well, I'm wondering if you did that, would the index, if your breakpoint was on line 9 rather than line 8, when you dragged back to line 9 again, would you not still have an index of 5?
I would. I still have an index of 5. It doesn't go back in time. So now what I'm going to do is set the execution to this and hit F5 and look at my console window. I just made the world explode.
Again.
So yes,
Yeah,
be very careful with that. Okay, so that's really mostly what I wanted to talk about in regards to basic debugging. And just for people who are interested, if you hit F11 on some sort of standard object and you see this, don't freak out. Actually, never mind. I want a complete implementation of the C++ standard library for this week's homework. By the end of the class, or end of the series of this class, we will be talking about all this cool stuff. Templates, pointers, references, but not today.
Phew.
Okay.
So any more questions about what's been covered debugging-wise? Do you know of the debugging schema in other IDEs? Other IDEs are available.
I don't know. Sadly, I just don't know. They all have, every debugger, I've used debuggers in quite a few different IDEs, not extensively, but they will all have some sort of watch window, some sort of locals window. They'll always have a call stack, and they'll always have the ability to step over, step into, or step over a particular line of code. Is there a hotkey to get to pin the pop-up, or is it supposed to be left click? Not sure. I've never used a hotkey to pin a variable to my thing. I've always just used the pin button. I executed the if false by breaking into the debugger, dragging this pointer onto line 17, and then hitting F5. See you, Bob.
Yeah.
It is very dangerous.
That's the key thing. You can. I mean, that is the only way you could get into that code. So it's not something you necessarily want to be doing.
Yeah, unless you know exactly why you're doing it. Okay, any more questions about debugging? Because we're about to jump into for loops. I mean, pretty much everything we're about to cover is going to be very straightforward from here on out. And
so Nelson, why do you keep forgetting to increment your index in while loops?
Yeah. Basically, a while loop is the simplest loop, and it's also the least powerful loop. So the developers of languages realized that while loops, while great, they had some very common instances where people would be doing stuff like this. For example, I am starting at the index 0 and going to the index 4. So I'm stepping over this code 5 times, and this scenario is so common that they invented a loop that's specifically designed to handle this scenario. So for example, I can say for int I equals 0, I smaller than 5, I plus plus, cout, I is I, new line, run, and we get what we expect. So what we have here is a for loop. And a for loop is basically syntactically similar to a while loop in that it starts with a keyword, opens up parentheses, and then enters a block, which is a very common theme for curly-based languages. But what's going on here is inside the parentheses is where things get interesting. Inside the parentheses we have three parts. We have the variable declaration, followed by a semicolon. The semicolon is required. Followed by the expression, followed by a semicolon. Again, this semicolon is required. Followed by an action. I do want to point out that none of these individual components are required. The semis are, but none of these individual components are, meaning I've just coded a valid for loop. However,
it's dumb.
Yeah, it's dumb. It's a stupid for loop. I hate it. But what we have here, though, is we have it filled up with a very common scenario. We initialize we declare a variable, initialize it to 0, set the condition to I is smaller than 5, then increment it on every action.
It would be better to say it the other way around, but yes, Bando, that while loop and that for loop do the exact same thing. In fact, if you rename your I to index, they will...
Well, I can't because of scoping,
same.
but if I say this, then they'll do the exact same thing. Is the I variable initialized in the for loop localized to the for loop? Yes. The I variable is only in scope of the for loop.
That's what bit me in suggesting that just now. I didn't think about the spare index variable that you've got at the top.
No.
Essentially, this is they're turned into the same thing behind the scenes.
Right.
The for and the while. And so this is very much... Well, you can see it's just a shorthand for all of the same things are there. You could literally have cut and pasted the bit pieces of the while loop into that for loop. Oh, here we go. Dun-ta-da.
Uh-oh.
Run.
I actually have no idea what's about to pop up. Because I did a print screen.
Ponies.
Well, hold on. Let me make sure I don't have anything horrible on my screen. Okay, no, I don't. Ah, sweet. It didn't follow through. Oh, wait a sec. It just grabbed a screenshot from inside the VM. That's actually cool. Okay, so basically what's going on here is a very basic level. This is here. This is here. And this is here. So basically we have the exact same code that's simply being moved in a more better way. So we have the same components. We have the initialization of the variable. We have the condition, which is up here, and we have the action. In fact, this is also how the execution works. The initialization is only executed once at the beginning of the for loop. The condition is executed every time, including the first time, just like in a while loop. The action is always invoked at the end of the loop. So any questions about... what?
I was just going to go back to the scope thing on the index. The other good thing is if instead of having... I mean, if you had another for loop that followed on, you could call that I as well. These are... because the thing is, these are throwaway... these iterators are the throwaway variables that are just you're literally just using to perform the same thing a number of times.
Yep. Okay, any questions about for loops? Because, like I said, we're basically... the string stuff was the hard stuff in this class. Everything else is going to be, hopefully, pretty straightforward.
Do you just want to show them it doesn't have to be a ++ operator?
Oh, sure. we could say for int I equals 100, I is greater or equal to negative 100, I minus equals 25. So we get I at 100 and then counting down by 25 until negative 100. If you increment I in the for loop but break early, is I still in scope after exiting the for loop? No. I is never in scope outside of the for loop. I is scoped to this scope, meaning I is only accessible from within this scope. And we're not constricted to just using integers either. I can say for bool I equals false, I does not equal true, I equals not I. As you see, we get I equals 0, then it stops.
If on line 18 you inserted something like if such and such, no, that still wouldn't work. You're only ever going to get 2 of that, aren't you?
Because there's only 2 states.
Well, actually, no. What would happen if you set it to true, set it to false inside the loop?
We would get an infinite loop.
Yeah.
Or, sorry, if I set it to true.
That's what I was aiming for.
If I set it to true, we'll get an infinite loop. Because the action always happens at the end.
Indeed, a pine paradox, Storm Clover pointed out. Well, see, now on Monday you set that as an exercise. So do you want to come up with another? You set the 100 to minus 100 one as an exercise. Do you want to?
Well, I did delete it from the screen. So how about? All right. So how about everybody?
Oh, I know. You could do 100 to 0 to 100 again, like that, in one loop.
That'll be.
It's quite simple.
Well, you'll have to.
Isn't it?
You'll have to reverse the direction of the action, like in the middle of it, which would be confusing.
Oh, you wouldn't.
If you wanted to go from 100 to 0 back to 100, you'd be counting down, then counting back up.
Yeah, but you can still do it.
You could, but you would have to have an if statement inside there, or a ternary in the action.
Or an absolute operator.
Or, well, there is no absolute operator in C++. There's an absolute method, and I can't remember.
What?
I can't remember which header it's defined in.
That's what I was aiming for. There's only one absolute of the number. Print the absolute. And then it bounces.
Yeah.
Okay, you come up with something then. I'm done thinking for the night.
Well, fine. How about 50, 55, 60, and then all the way up to 1,000 with commas, without a comma at the end. Wow.
Yay!
Okay, so go ahead, write a for loop that prints this output exactly. And by the ... I do just mean to continue this pattern onwards, not to literally print out ...
Have you reset the participation thing?
Yep.
So go ahead, click participate.
Recording. All right, so we're back. So to go ahead and get this to work, what we can do is we can say for int I equals 50, I smaller equal to 1,000, I plus equals 5, and then if I is greater than 50, see out a comma, and then see out I. Oh, come on. I hate arrow shake. I hate it. So now you see that we get the output that we want.
Do you want to show the opposite way of achieving the same thing, just in case people are going, oh, but I did it this way?
Well, you could do if I is smaller than 1000, print out comma. I hate the stupid focus bug. You can do it with no ifs.
Could you just point out the answer to Bando's question, doesn't it? Why bother with the if I is greater than 50?
Because what happens here is I want a comma to be printed out preceding every item after the first item is printed out. So if I didn't have this if statement in here, a comma would be added at the beginning of my program, which isn't what I wanted. Instead, I want the comma to be added everywhere but the beginning and the end. I prefer to do it this way than the other way because, generally speaking, for loops, you will often find yourself calculating the upper bound. So, for example, the size of an array or some other calculation. And I find it's generally easy to reason with if you do it this way because you only have to think about the initial starting point. So you only have to say if I has been made bigger than or smaller than the initial point. It's generally easier to reason about.
Well, for the end case, note that he also had to shift the order of the two parts of what's going on there. Because what's going on here is he's outputting the comma, space, I each time round, apart from the first time.
Right.
Whereas the other way around, he's doing I, comma, space, except for the last time round.
Yeah. Okay.
All the best people are.
Except for everybody else who's better and are right-handed. So if, or for loops, everybody go to for loops. We're about to move to range-based loops. We're not going to spend a whole lot of time talking about range-based loops. And yeah.
It's just worth noting what Chris put into the questions panel, which is true, but it's not really in the spirit of the thing.
Yeah.
He said you can do it with no ifs, just add cout 1000 after the for.
Yeah, but meh.
Which is true, but that's a bit like using array.sort to put in the other thing. Not that I'm bitter. Anyway, carry on.
Okay, so let's go ahead and talk about range-based for loops. I'm going to go ahead and fire up my Windows 8 virtual machine. Or how about my Ubuntu machine? Because my Windows 8 virtual machine is configured to automatically take everything that someone sends me in chat on Facebook and plaster it across the screen, which fortunately didn't cause too much of an issue last time, but could very well potentially be embarrassing.
It certainly could, some of the things I've seen. The number of times I start a conversation with just abuse on Skype.
Yeah, and you're not the only person who would get a hold of me who would do that, so yeah. So what I'm going to do is I'm going to jump into Ubuntu, and the reason I'm jumping into Ubuntu is that the Visual Studio 2010 compiler does not support range-based for loops. GCC with a special compiler flag will support range-based for loops, and Visual Studio 2012 will support range-based for loops. Let's go ahead and just talk about their syntax. Talk about the syntax really quickly. Basically, a range-based.
Let's talk about what they are.
Sure, they're a feature in C++ 11 that is equivalent to a for each loop in C#. They're very, very similar in how they work under the hood. So, for example, let's go ahead and look at their syntax. So if I go ahead and declare an array, a 5-element array, and I wanted to loop through all the items in this array, what I could do is say for int item :r and type in cout item new line.
And that is a colon on line 9.
Yes. So now if I run this, you see that down here in the console I get 1 through 5. So yeah, this is what they are. Now, range-based for loops, you're perfectly allowed to use them if you're using a compiler that supports them. There's not a whole lot to explain about how they work. They simply enumerate all of the items within an array or in a collection. I do want to point out that they do oh god, pointer puns. They do support collections as well. And string, for example, is a collection of characters. So what I could do is say string stuff equals hey there. I could loop through all the characters in this string.
And a quick answer to Marcel, he said, is for each similar to the for loop in Python? It's similar to if you do for object in range, for object in collection, rather. A for loop is the same as the for I in range length of layout.
Yeah. And I do want to quickly point out right here, what's going on is very interesting. The for loop is actually, in the case of a string, expanding into more code. What this code compiles into is this. So as you see, we get the exact same output. What's going on here is this is what's called an iterator, and is a common thing that we're going to get more in depth into once we start talking about collections. The range-based for loop will simply expand itself into this code and allows us to iterate over items in a variety of different containers, such as vectors or lists or maps or strings. So are there any questions about range-based for loops? Any questions? Are people even still awake?
Sorry, what? I was asleep.
Well,
Dawn Clover likes turtles.
wow, is this just like a random tired meme fest today?
I think it's Friday night.
Okay, so let's go ahead and move on to switches.
I was just going to say that.
Got what?
It's got a lag fest as well.
Yeah. Ugh. Okay, switches. What's a switch? A switch is basically similar to switches in many other languages. It basically just allows you to switch on a particular value and execute code conditionally. Sounds a lot like an if statement. Well, it is. So let's say we have an int choice, and we grab that choice from the user. And we say, we give them a prompt. Enter a number, 1 through 4. What I can do is open up a switch block. And switch block, again, follows the same, the same sort of structure. We start with a keyword, open some parens, then open some curlies. Inside the parentheses goes an expression. So let's go ahead and put an expression in here. The expression that I'm putting in here is, well, choice, because choice is an integer, and by naming it here, it turns into an expression, and the value of the expression is going to be whatever data that variable contains at the moment, which is set by cin. So how do I conditionally execute code based off the value of this expression? Well, I add case statements. So I can go ahead and say case 1, cout, you entered 1. Awesome. Case
Note
2.
C++ is very dodgy formatting for case statements. What is it with you and Flora, dude?
Funny story about a client I'll tell you in break.
Excellent.
Okay, so this is what the switch statement looks like in C++. And it is very straightforward. I do really quickly want to point out to anybody reading this code who might be familiar with breaks and continues in the context of looping, this break keyword has absolutely nothing to do with looping. This break keyword in this context is associated explicitly with a switch statement and in no way indicates that switching has anything whatsoever to do with looping. I just wanted to make that very clear because there was a lot of confusion in Monday's class about that. So what's happening here is we're switching on this expression and we have a bunch of case statements that all have constant values. And just like a bunch of nested ifs, or not nested ifs, but a bunch of repeated ifs, we get the behavior we would expect. So if I run this program and type in 3, it says I entered 3. And if I type in 4, it doesn't like it. And then when I type in, a big number, it tells me I fail at life. There's not a whole lot.
So what happens if you miss it? So what happens if you miss a breakout then?
Well, C++
It behaves differently.
C++ behaves differently than C# as far as following through. C++ allows following through, whereas C# does not, and so do quite a few other languages, because missing a break is a very common thing when dealing with switches. But now watch what happens. If I go ahead and hit 1, it says, I entered 1, and then it says, I entered 2. Well, what happened? Execution fell through the 1 statement, the 1 case, into the 2 case. So, yeah.
Cool.
And then we have the default case, and the default case, not surprisingly, will execute given that none of these additional cases were matched. These must be constant integer values. I just want to really, really stress that. These must be constant integer values. Or
They have to be integers.
Or float values, but you wouldn't want to switch on a float. That would be bad because of rounding errors.
No, I was just thinking, so you can't switch on, if you had 4 choices, or 3 choices, cat, dog, and fish, and somebody typed in dog.
Well, no, you can't switch on string characters, or string literals. Because it must be an integral constant value. Expression, sorry. Bools, I believe, are allowed, even though I've never done a switch with a bool. I'm pretty sure they are allowed, and the reason I'm pretty sure they are allowed is because C# basically treats them like integers anyway. And not surprisingly, this compiles. I wonder if this would compile too. Yep, that compiles. Ooh, I wonder about... Thank you.
Well, finally, something that didn't compile.
Yeah. I didn't know if it would let me statically cast a character pointer to an integer, which is possible to do, by the way, inside of a case statement. I've just never tried to do that before because it's, well, absolutely ridiculously pointless.
But basically, as Nelson said, these are essentially equivalent to doing an if followed by a series of else ifs followed by an else.
Yep. As far as my opinion of switches, I tend to stay away from them because of their limited capabilities. Their very vertically offensive layout, and the general hatred I have towards treating everything like an integer. I typically do avoid them, though I do find myself using them in certain circumstances. So for example, if let's say I have a string product name, and I wanted to assign product name to something different depending on the choice, in this case I probably would use a switch. I would say switch choice, but then I would format it like this. I would say case 1, product name equals product 1, break. Here's a situation where I would use a case or a switch because it's less vertically offensive. Can a case switch be an expression like x is smaller than 4? No, it cannot. Everything right here, this right here, must always be a constant integer value.
Could you zoom in a little?
Do you need the break on default? I can't remember. C# you do. Nope.
Shane, are you just trolling, or is that a serious question?
Do go-tos work in switches? Yes, they do. We don't talk about go-tos here. Any more questions about case switch statements? They're very straightforward. Must be an int because of the type assigned to choice. No, it must be an int because the language specification informs me that it must be. Based off this error, it says expression must be an integral constant expression, meaning it must be a constant expression that evaluates into an integral value, which is going to be any whole number, essentially. And remember that that you can...
So it could be a char, then?
Yes. Because a char converts into an integer. So switches are really limited in their use. Yes, they are. They have uses. I typically find myself not using them very often. Just out of habit because they are limited. But like I said, I think this looks kind of sexy. So there you go.
Cool. So is any more questions on switches at all? Doesn't appear to be.
Yeah. Okay, break and continue. How's the performance with the switch? Performance with the switch is it's going to be pretty much the same performance as a bunch of if statements. Actually, when was the last time I stepped outside? Kevin?
I don't know.
Because we're about to talk about break and continue, then we are going to terminate the class for today.
Well, and mention the homework.
Yes. So I say I'm going to go ahead and pause the recording. And if anybody has questions, please post them in the webinar questions panel. Questions about anything we've covered today. We're only going to be covering one more topic, and then we're going to be talking about homework. So, yeah. All right, so resumed. Let's talk about break and continue.
Cool. Which is what?
Not this.
Well, okay. Have we not already talked about... Oh, yeah, beat me to it.
This is not what we're talking about. I just want to reiterate that this break has no correlation whatsoever to looping, which we're about to talk about. Okay, let's talk about looping and break and continue. Well, break and continue are very straightforward concepts. Basically, if I entered an infinite loop and I wanted to say something like cout, enter your name, for example, I did string name, then cin name, and say if name does not equal Nelson, or sorry, if name equals Nelson, then break, otherwise cout liar. What's going to happen here is that this loop is continuously execute.
With an extra carriage returning. Very.
And so on until I answer correctly, at which case the loop will terminate. So,
cool beans.
By reaching this break statement, we break out of the while loop. Any questions about looping? Or breaks? No?
So what about if you wanted to do that, but then still be able to enter the name again afterwards?
Right. So if, let's say, name equals rainbow dash, we could say cout you wish, and then continue. Now, continue, what this is going to do is this is going to continue the loop again without executing any more code inside of the loop. So, for example, if I hit F5 and I type in bleh, it's going to say liar. But if I type in this, I get something else. It says you wish. And then the loop continues without executing line 26. And then finally...
It continues from the start, is the key.
Right. It continues all the way at the top of the loop. So if I finally type in the proper thing, the loop terminates, and it exits. How do we do with string case, uppercase versus lowercase? I'm going to save that for another discussion. If you have an if nested inside of a for loop, does it break exit for the for loop? Yes. If we have an if statement inside of a for loop, so for example, for int I equals 0, I smaller than 10, I plus plus, if I want to say if I equals 4, or if I equals 3, I could cout, and I could break. Otherwise, I is this. Or, sorry, 4. I was thinking backwards. So now if I run this program, you'll notice it says, well, not properly formatted because I forgot a new line. It's going to loop until it reaches 4, at which point it throws up its hands and says no more, and breaks out of the for loop.
But if you put in before line 10, something like if I equals 3, if I equals 4, continue.
If instead I said if I equals 4, continue, what's going to happen is, if I run this, it's going to simply not print out 4. So break and continue work on all loops. Yes, all loops support break and continue. Any more questions about break and continue? I am going to show a demonstration of how we can deal with break and continue in regards to nested loops in a moment here. But before I get to that, are there any...
There was somebody asking about a loop keyword.
No, there's no such thing. Is there any way to restart a for loop? Well, yes. you could always just set I back to 0. We could say, we could say I equals 0. And I've restarted the for loop. But you'll notice it never terminates. Are there any, is there any others that work with continue and break other than for loops and switches? No. Continue and break work in the context of looping, and looping only. Break and continue must be in a loop, with the exception of a switch statement. But remember, the break in a switch statement has to do with the syntax of the switch statement, the definition, the syntax of what was defined as a switch statement. It's not the break and continue we're referring to right now. Okay, let's talk about nested loops. So if I wanted to have a nested loop,
oh, somebody did just say the break and continue need to be in a loop.
Yes. If I were to have a break right here and run this, or try to compile it, C++ actually, to its credit, says illegal break. And the reason I say it's to its credit is
break out of.
Based off of previous things that C++ does for you. I'm surprised the behavior doesn't, like, I don't know, shut down your operating system or something.
Oh, not doing so well on giving people faith in C++.
It doesn't do a lot for you, but that is its strong point. C++ is a desirable language in certain circumstances because of the lack of security and the lack of features that it gives you. And I know that sounds contradictory, but I'm being absolutely serious.
No, absolutely. It lets you do what you want and assumes you know how to. Essentially. It leaves it up to you to make sure you're not doing something dumb.
Yep. Can't you return out of a loop? You can return out of the loop. If I were to say, if I equals 5 and j equals 2, if I say return 0 right here, this will simply end the program the second it gets to this. Okay, so let's go ahead and talk about how to break out of nested loops. Because
people were just querying about the postfix again, as opposed to prefix.
Oh, I'll talk about after this.
Is relevant to looping.
Yeah, I'll talk about this after. Okay. A lot of people like to do this. They think this is an appropriate solution to the problem. This is not something you would ever want to do. Instead, to properly encode this logic into C++, to break out of a nested loop, we need to do some more logic. Because if I do a break right here, it will break out of the innermost loop. So you'll notice that it still continued, but it broke out of the loop when I equaled 5 and j equaled 2. So when I equaled 5, you'll notice it only gets executed 3 times for 0, 1, and 2. To break out of a nested loop, simply set and exit Boolean. Set that Boolean to true, break out of the inner loop, and then in the outer loop, check to see if we need to exit, and then break out of the outer loop.
But that's so much more writing, Nelson.
Yeah, but it's so much more correct.
But it's so much more writing than just using a goto. Why is that not better?
Because gotos are a slippery slope that will ultimately lead you down a path that you might never recover from.
I was hoping you'd explain it in a way that made it clear to people. Because, like Kraus said, actually goto seems like it's a bit more readable there. Yeah, but
it is, but it's not.
So the thing is, like, with go to exit, does it is that what do you get out of this other than
you get readability?
Avoiding go tos.
You get readability, and you avoid a bunch of potential problems. Like for example, you can easily break go to code so easily, accidentally. In addition, that go to the label is so far away from your for loop, and it just makes it easier to break code in the future. That's the thing about go tos is they're so easy to break your code with. This way, by not using a go to, we're forced to encode the intention of our program, rather than relying on something that could very legally be placed in a position that's invalid, or maybe semantically invalid, but not syntactically invalid. So for example, if I were to return to the goto example, this code is more difficult to read, but it also could lead to issues, because I can take this exit and I can stick it above the for loop. I can take the exit, I can stick it after the return 0. I can take this exit and I know we haven't covered functions yet, so ignore me, but I can stick it right there. I mean, go-tos are just horrible, horrible things, and they just provide a more brittle...
and dirty, no, you won't get banned, but there's a good chance you'll fail your homework.
Yeah.
And somebody said, wouldn't it be cleaner to just while not exit and encompass both for loops? And I suppose not in relation to the go-to. I think, yeah.
There's not much more... There's nothing else you can do. I mean, you could say, while in your for loop, you could say, while I is smaller than 10 and not exit, for example. This would have the same behavior. Okay, so are there any questions?
No, Bando. Cool. Doesn't look like there's any more questions then. So, homework.
Alrighty.
Do you want to grab the homework thread?
Yep. Homework.
Oh, I suppose the pre and postfix.
Oh, right. Prefix, incrementation, and postfix incrementation behave similarly, but the difference is, for example, if I have int I equals 0, and I say cout I++, and then cout comma I, what I get with this example is 0 then 1. And the reason I get that is the postfix increment operator will only apply the increment after the expression has been evaluated. However, the prefix increment operator and decrement operator, this is valid for both, the prefix increment operator will perform the incrementation, or is that even a word? Incrementation.
Is which a word? Incrementation, yeah.
I don't like that word. I think it sounds just not dirty, but I mean...
Just say incrementing.
Incrementing. I just don't like it. It's just incrementation. It sounds like a horrible word. Anyway, so what's going on is with the increment, the prefix The prefixed increment operator, what happens here is the increment happens before the expression is evaluated. So as a result, in the second example, we get 1 and 1, whereas with the first example, we simply get 0 and 1 because the expression is evaluated prior to the value being incremented.
Now, Deity Games has managed to jump straight to the really awkward part of that.
This doesn't behave any differently. J starts at 0 and J ends at 9. The reason this doesn't behave differently is this action is in itself an expression, meaning the action has no correlation to any other expressions that might be before or after it, meaning that it is always executed as a unit. So pre-incrementation and post-incrementation are irrelevant.
If you think back to how this was laid out in terms of being a while loop instead, that always happens after everything else has happened. So it doesn't matter, you're not actually doing it at the same time as you're C-outing it. Nelson?
Yes?
Are you with us?
I am with you. So are there any more questions?
Nate Nelson.
You what?
Are we still, I mean, are we on break or something?
No. I'm just waiting for people, but they're...
You keep going away and typing at something else.
Actually, if you must know, I vaguely remember somewhere where Eric Lippert, one of the senior developers on the C# programming language team, was talking about nested loops and breaking out of them, and I remember him venomously going against using gotos, and I just wanted to read his specific answer to that, other than they were just ugly, which I think is probably his specific answer, but still. Okay, so let's go ahead and talk about homework.
The more observant among you will have noticed it's been posted, well, since Monday, because it's the same homework as Monday.
This is your homework. Submit a modified version of last week's homework. Beginning of the program, allow the user to enter 4 products, name, and price. You do not need to support names with spaces in them, but you may if you wish, and you do not need to worry about input validation. The rest of the program will continue to behave as before, except the products must be displayed to the user in ascending order of price. You may use the bubble sort algorithm to do that. No functions allowed other than main. And of course, feel the pain. But pain is good.
In fact, if you scroll down a few posts past Wedge Bob's to probably elevating, no, somebody will have posted, I saw it, that nice YouTube video. Oh, there it is, link in elevating's post.
I watched this video. Okay, so yeah, just click on that link and you'll learn things.
I assume it's the guy with the playing cards.
I don't think it doesn't look like he has playing cards.
Deity Games. Methods?
No.
No functions other than main.
Okay, any questions about the homework? And Brady, yeah, thanks for reminding me. I'll do that after we get done with homework. So, questions? I guess then that this is it.
And Dawn Clover, the link to that thread is in the live classes along with that. It's always there after once the homework is up. NATO. Oh, okay. Grab me on Skype after.
Okay, so I guess this concludes week 3 of C++ 101. Goodbye, everyone.